All right, this video is being created to go over the questions in section 2.3. Some of these may have gone over in some of the classes that I taught yesterday, but there'll be a number of these that I have not. So this video will probably be longer than some of the other videos. If at any time you'd like to attempt these questions before you watch me do them, that'll be perfectly fine. So the first thing we're going to do is talk about solving the equations in these questions, and then once we get to some of the problems involving fractions, then we'll talk about how we get rid of the fractions again in these more complicated equations below here. So you'll see in 2.3 the equations get more sophisticated. These type of equations are usually going to have fractions or parentheses or both. And if you have both, you probably want to try to get rid of the fractions first before you get rid of the parentheses. And we'll take a look at all the nuance of how all that works out to be. So we're taking a look at question 1 right now, which is going to be 5 times 2y minus 1 minus 2 times 3y equals 1. So that's a pretty long equation. And it's going to be difficult to combine like terms of any kind unless we do a little work to get rid of the parentheses here. Okay, so we've got a couple things we need to address. We need to distribute 5 through this here. We also need to take a negative 2. We need to multiply 3y by this. This would be a case of distribution because we have 2 terms in the parentheses. Here in this parenthesis, we only have 1 term. So we do need to multiply the negative 2 by the parenthesis, but it's only 1 term, so we wouldn't characterize it as being distribution. So the only thing that's going to remain the same is going to be the equal to 1. So let's see what changes happen here. 5 times 2y, that'll give us 10y. 5 times negative 1 will be negative 5. Negative 2 times 3y, that's going to be equal to negative 6y. And now I no longer have any parentheses in the question. So one thing we mentioned in class yesterday, we're going to try to get the variables to one side and the numbers to the other side. So the only thing I need to move at this point is, see if I can get a different color object here. I'm going to go ahead and I'm going to move this minus 5 to the other side. So I'm going to write this equation now as 10y minus 6y equals 1, and I'm going to change the sign to make this plus 5. From this point, I should be able to combine like terms. So, and I'm going to bring that result up here, where I get 10y minus 6y is 4y, and then 1 plus 5 is equal to 6. And then if I divide both sides by 4, I'll get y is equal to, this is going to be 6 over 4, but it does reduce to 3 over 2. If you have a good scientific calculator, like a TI-30X or a TI-36X, it will often not only convert this to a decimal, but it should also convert it to a fraction into lowest terms. Okay. So the answer to this is going to be 3 over 2. Taking a look now at question 2. We have to do some distribution here as well, so I'll rewrite this problem here. This is going to be 11 minus 5 times a plus 2 equals 7 plus a. So just to kind of separate the workout from above to here, I need to distribute negative 5 through here. Everything else I can just bring down. So when I bring that work down there, I'm going to have negative 5a, because I need to distribute this now. And that's going to give me minus 10. So now I have 11 minus 5a minus 10 equals 7 plus a. Well, by using the technique that we use in class, we're going to have a lot to move here. We have 11 we need to move. We have negative 10 we need to move. And we need to move that plus a to the opposite side. So we're going to go ahead and we're going to do that now. So what's going to stay on the same side? Well, negative 5a is going to stay over there. And then we have 7 staying over here. A is going to move over from the right to the left as being minus a. And then here we have 11 minus 10. That's going to become here negative 11, and that's going to become plus 10. So remember, I box when I move, but when I move it, I switch the sign. Negative 5a minus a, that'll be negative 6a. 7 minus 11, that's going to be negative 4. Negative 4 plus 10, that's going to give me 6. So I have negative 6a is equal to 6. I divide both sides by negative 6, and that's going to result in a equaling a negative 1. So a in question 2 is going to equal negative 1 in that case. I'm going to go down to questions 6 and 7 before I discuss any more about like percents or decimals or anything like that. So I want to make sure that questions 6 and 7 are in full view, and then we'll talk about some of the earlier questions in a little bit. So is to solve the equation for x here. Now let's take a look at what we get for this one. So if I have, I'll do the work over here, 2x minus 1 is equal to 2x plus 2 times x plus 4. Let's get this down here. So if I have 2x minus 1 equals 2 times x, the quantity of x plus 4, I'll rewrite this as 2x plus 8. So now you have 2x minus 1 equals 2x plus 8. Now, I want you to observe, before we go further, that we have the same, we have 2x on each side, but we have different numbers. Since we have the same amount of x's on each side, this is like, there's no other x's here. We have a 2x here, we have a 2x here, but different numbers. Let's take a look at what happens as we move things around, okay? But I want to just kind of star this point here, because at this point, you should be able to tell what kind of solutions you're getting. If I write this as 2x, moving this over, and we get minus 2x, and then I bring the negative 1 over, and I make this a plus 1, 2x minus 2x is equal to 0, and 8 plus 1, that equals to 9. We have no variable in this question anymore. So if you get to this point where you have like a 0 equals a different number, or just one number equals a different number, we want to say for this question that there is no solution to this. And one way you could recognize that is if you start to see the same number of x's on both sides, but different numbers, like if you have one number left here and they're different, then you should be able to recognize there's no solution. If you have a hard time visualizing or understanding that, then just go ahead and work the problem to its conclusion to see that this outcome is not possible. Let's take a look at what question 7 says, so that we can do a little bit of a comparison with this. So I'm going to bring in some additional paper into this so I have room to do the work, because there's going to be a fair amount of it here. So and I'll move the paper up here a little further. So it says here this is going to be negative 3 times 3x minus 7 plus 6 equals negative 9x plus 27. So now the equations are starting to get big and they're getting ugly. We're going to go ahead and we're going to distribute negative 3 through this. Everything else can be just brought down as it is. Now we have 3 times negative 3x, that's negative 9x. We have negative 3 times negative 7, that's plus 21. So at this point here, it doesn't look quite the same as the other one did, because on the other one, if I can bring it down for a second, we had 2x with one number, 2x with another number. Here, if we look on one side of the equal sign, we have negative 9x. Here we have negative 9x. Here, we have only one additional number, and here we have 2 additional numbers. And we're not quite sure how those are going to combine yet. But a lot of people could probably see that 21 plus 6 is 27. So if you did happen to combine these as a side step, so I'm going to just take this to the side, because this is usually not the work I do. But if I were to take 21 plus 6, that would give me negative 9y, or 9x, is plus 27, by combining this, equals negative 9x plus 27. So looking at this, we have the same variable term, but we have identical numbers this time, so they're not different. So let's take a look at when we have a situation like this, how this impacts the problem. So I'm going to go ahead, I'm going to move this, I'm moving this, I'm moving this. That's going to give us negative 9x plus 9x equals 27 minus 21 minus 6. In this situation, plus 9x and minus 9x gives me 0. 27 minus 21 is 6, minus 6 is 0. So if 0 equals 0, if we get that for a solution in an equation, what that means is no matter what you put in for x, both sides are always going to be equal to each other. So the answer to this question is going to be all real numbers. So again, what's the difference between these two types of solutions? So let me characterize this. What's one thing the solutions have in common? X is no longer a solution, is part of what's included in the final step if you carry it out all the way. So if you have the x disappear, then you know it's going to be a situation where there's either no solutions or everything's a solution. What's the difference between no solution and everything being a solution? If you have two numbers that are not equal to each other, there is no solution. If you have two numbers equal to each other, then everything's a solution. So if you can keep track of that difference, you'll be able to understand those questions and do those more successfully. Okay, let's see if we can find a few other questions here for solving the equation, and then we'll start taking a look at some of the fraction work, because we're going to come back to that page here. So we're going to go ahead and take a look at question 9, because question 9 seems to be pretty complex, and I'm going to go ahead and use a page for this again for question 9. So the equation is 9x minus 25 equals 2 times 3x minus 8 plus 3x minus 9. So that really looks like a long and terrible problem, but like we talked about in class before, the first thing I want to do is I want to get rid of the parentheses. So I'm going to multiply 2 through here, and I'm going to bring everything else down first, just so I don't lose it. So 9x minus 25 equals, and I'll bring this down in a moment once I distribute, 3x minus 9. So now I'm going to take 2 times 3x, I'm going to take 2 times negative 8. 2 times 3x is 6x, then 2 times negative 8 is going to be negative 16. So now I have a bunch of terms here that I need to kind of worry about consolidating and moving around. So what am I going to do first here? I'm going to move the negative 25 to the right. I'm going to move 6x to the left. I'm going to move 3x to the left. And let's see what kind of solution we get here. So everything else that's not boxed, I'm moving. So like I'm going to keep 9x here. I'm going to keep negative 16 here. I'm going to keep negative 9 here. 25, or negative 25, I'm going to move as plus 25. 6x, I'm going to move as negative 6x. 3x, I'm going to move as negative 3x. Now, if you're beginning to see where this is going in a more complicated way, 9 minus 6 is 3, 3 minus 6, 0. Let's see what we end up with here. Negative 16 minus 9 is negative 25. Negative 25 plus 25, that's equal to 0. So, is this no solutions or all solutions? Remember, if they're equal, it's going to be all solutions of x are real. And that's how this problem is carried out. So for this one, it's going to be, the solutions are going to be all real numbers. Now, for the remainder of these questions here, I think most of these, I'm thumbing through this myself here, most of these are going to involve some work with fractions here. So I'm going to go back and kind of show you how to navigate the work with fractions, and then we'll take a last look at decimals next. So I'm going to go up here and show you how to get rid of these. So the equation is a little more complex. It's a little ugly, but I'm going to apply the same technique that was taught in section 2.2. So I'm going to take this equation now, 11 over 15x minus 1 over 5 equals 2. And I'm going to go ahead and multiply this by 15 times 5 over 1. If I multiply through here first, 15's cancel, leaving me with 5 times 11 times x. Or that's going to leave me with 55x. Next, I have minus 1/5. The 5 here cancels the 5 here, leaving me with 15 times the negative 1, so that's going to be minus 15. And then we have equals, all we have here is 2. The 15 and the 5, they're not canceled at all. There's nothing in the denominator of this 2 to cancel with. So 15 times 5 is 75, times 2 is going to be 150. So we have 55x minus 15 equals 150. Now, again, some people are going to be really strong in their math. They're going to be able to do this without any aid or without any special techniques. But I'm going to go ahead and rewrite it up here like I've done in class. And I would write this as 55x equals 150, moving the 15 over and making that plus 15. We're getting 55x equals 165. Now, once I have that worked out, I can divide both sides by 55. And that's going to give me x is equal to 3. And that's going to be that problem worked out. Okay, I'm going to expand the work on the next question. I'm going to give myself a little more room by using another piece of paper for this here. This is question 4. And this one we have another fraction here. So I want to take a look at how we handle the fraction in this question. So, and here we have 2 times the quantity of x plus 1 divided by 4 equals 3x minus 2. In this particular problem, it appears that we only have a fraction of one part of this. But I'm going to go ahead and multiply the whole thing, and I'll just put this outside anyway. Multiply this by 4 over 1, and let's see what happens. We have a parenthesis above 2. What I'm going to tell you, since the whole thing is being underlined by this one fraction, just ignore it for the moment. We're going to bring this down as is, because the 4 and the 4 here are going to cancel, leaving me simply with just 2 times x plus 1. And then we'll bring the equal sign down. Now we're going to have 4 times 3x, nothing cancels here, and 4 times negative 2, nothing cancels here. So 4 times 3x is going to give me 12x, and 4 times negative 2 is going to give me negative 8. What we don't have in the problem anymore, we don't have parentheses anymore. So now I'm going to go ahead and distribute this, and this is going to give me 2x plus 2 equals 12x minus 8. And now I'm going to move some things around to both sides in order to show the work on the screen here. I'm going to bring this up here with everything properly moved around. So I'm going to keep the, what am I moving? I'm moving the plus 2. I'm moving plus 12x. So that's going to be 2x minus 12x equals negative 8 minus 2. So I have 2x minus 12x. It's going to be negative 10x. Negative 8 minus 2 is going to be negative 10. So if I divide both sides by negative 10, then finally x is going to equal 1. And x being equal to 1 is going to be the final solution to that problem. And we're going to go ahead and put that here. We're going to flip over to the next page of problems and work on a few more of the later questions that have fractions in them and see how we handle these. Okay. So let's take a look how we handle this. And if some of you are okay with doing these on your own, that's fine. There are, in fact, a few different ways that you could handle these so that you could solve them. What I would like to do is just get rid of the fractions at first, but it can make it a little more complicated. So let me just kind of show this work here. Let me pick a different paper here. Yeah, as I mentioned before, these are not professional videos. You're not going to see the smiling lady here, but hopefully you get some good techniques that will help you be more successful in class. So we have the quantity of 3 times x minus 2 divided by 6 equals 2 times the quantity of x plus 1 over 10. So there's our problem. I have 6 and 10 down here. Guess what I'm multiplying the outside by? 6 times 10 over 1. So I'm going to put the equal sign down below here. What cancels? The 6's. But what's going to leave me with is going to leave me with 10 times 3. And here I'm just going to multiply the 10 by whatever's outside. 10 times 3, that's going to give me, in this case, 30 times x minus 2. Go here now. Here the 10's cancel, leaving me with 6 times 2. That's going to give me 12 times x plus 1. What have we gotten rid of? We've gotten rid of the fractions. Now we have to deal with the parentheses on each side by distributing accordingly. So we have 30 times x is 30x. 30 times negative 2 is negative 60. Then we have 12 times x here. That's going to be 12x. And by the way, I apologize, it didn't show my distribution work here. 12 times x is 12x, and then 12 times 1 is 12. So now we have a much simpler equation. No fractions, no parentheses anymore. So I'm going to just move a few things around here, getting 30x minus 12x equals 12 plus 60. And anytime you ever feel like you're a little lost or confused, you can play these videos again. So it's not like you can't ask me a question because you're here just listening to the video, but you can stop and pause the video and see if you can figure this out for yourself. 30 minus 12, that gives me 18x. 12 plus 60 is 72. If I divide both sides by 18, x is going to equal 4. And that is going to be the final answer for question 8. Now, you're not going to see this exact question in your homework, but you are going to see a question similar to it. Okay. Let's take a look at another problem. Let's go to question 10 now. And again, I'm going to use another part of paper for this here. Okay. So the work for this is going to be x plus 25 over 15 equals 2 over 3x. Now, if you're just beginning to catch on to this technique and you want to pause the video to figure out what part of this work you want to show, like what you want to multiply this through by, pause it and then come back and then see if you figure it out. Assuming you haven't paused it, I'm going to go ahead and put this down. And since I have a 15 and a 3 down here, I'm going to multiply by 15 times 3 here. And it's going to be over 1. So I go through each term that's separated either by a plus sign, a minus sign, or an equal sign. 15 times 3 times x. Well, there's nothing to cancel with, so 15 times 3 is going to give me 45, or is going to give me 45x. Next, 25 over 15. The 15 on the outside here cancels the 15 on the inside, leaving me with 3 times 25, or plus 75. Here, we have a 3 in the bottom, so the 3's cancel, leaving me with 15 times 2 times x, or 30x. 45 plus 70, 45x plus 75 equals 30x. So what I'm going to do now, I'm going to go ahead and I'm going to just move this 30x over, and then move the negative 75 over, so it's going to be 45x minus 30x equals negative 75. And that's going to be 45x minus 30x is equal to 15x equals negative 75. And then if I divide both sides by 15, x is going to give me negative 5. And that's going to be, let me put that down there just because I saw it was invisible. So x will equal negative 5, and that's going to be the final solution to question 10. For question 11, again, if you want to try to look at the problem question 11 here, I'll go ahead and write it down, and let's see if you can figure out for yourself here. So we have x over 5 minus 6 equals x divided by 7 minus 4. See if you can figure out what we're going to multiply this by, what we're going to multiply through to get this done. All right, maybe you paused, maybe you didn't. But since we have a 5 and a 7 down here, I'm going to multiply this by 5 times 7. So when I do that, the first term, the 5's cancel, leaving me with 7 times x, or 7x. Next thing, negative 6. Nothing cancels the negative 6. So it's going to be 5 times 7, 35, times 6, which is going to be negative 210. So this is going to work out to be negative 210. I'm going to put an equal sign here. Okay. So if I have x over 7, 7's cancel, leaving with 5 times x, or 5x. With negative 4, nothing cancels here, so it's going to be 5 times 7, which is 35, and then negative 4, which is going to give me negative 140. So now we've cleared the fractions out of this. We have 7x minus 210 equals 5x minus 140. Moving things around, that's going to give me 7x minus 5x equals negative 140 plus 210. Okay, now if you need a moment, because I'm going through these quickly, you always have the capability of pausing this to kind of understand why I'm taking what step. So 7x minus 5x will be 2x. Negative 140 plus 210 is going to be 70. So if I divide both sides by 2, x will equal 75. And that's going to be the answer in this case for question 11. Let's take a look at question 12 now. Now, if you take a look at question 12, hopefully one thing that you do recognize in this question, if you have 14 over 6y plus 2 over 2, hopefully one thing you recognize that 2 over 2 is 1. But again, just to stay consistent with my technique, let's say you don't see any of those things. Because 14 over 6 can be reduced to 7/3, and it actually makes the question a bit easier to do. But let's say you don't recognize any of that. you can still apply the same technique that I've been showing in class. And for this, let me just get a clean sheet of paper here. And that's going to be 14 over 6y plus 2 over 2 equals 2y minus 4. And I'm just going to go ahead and multiply through by 6 times 2 over 1, just to keep things consistent. So here again, 6's cancel. 2 times 14 is 28, times y is y. So the first term is going to be 28y. The 2's cancel, leaving me with 6 times 2, or 12. Here, at this point, nothing's going to cancel. There's no more fractions. So like 6 times 2 is like 12. And then 12 times 2 is 24. 12 times 4, that's going to be negative 48. So now in my problem, I have 28y plus 12 equals 24y minus 48. So what am I going to do here? I'm going to go ahead and I'm going to move the 24y over. I'm going to move the 12 over, so it's going to be 28y minus 24y equals negative 48 minus 12. Combining these gives me 4y. Combining these gives me negative 60. And if I divide both sides by 4, y equals negative 15. So there's the work in all its entirety. And that is, I think, the last problem I'm going to show with working on fractions, but I'll just kind of take a quick look at this here. I'm going to make a second video to walk you through the rest of section 2.3 and include that as well.